Here we have an Asus laptop model A55V. What have we got on the keyboard? Chinese characters, so maybe a Chinese market or Japanese market release. Are they? I'm not sure what they are. I think they're Chinese. Anyway, doesn't turn on, doesn't charge, no lights. Plug it in, no lights. So what causes that, you might be asking? Well, you're asking the wrong person, because I don't know. But let's see if we can find out. Okay, so we've got the scope on the screen at 5 volts per division. We should be having about 19 on the input. So let's check. This is our DC in jack, comes in through here. We should have 19 volts on this pin here, and we do. Let's just get you on the screen a bit better. There we go. Yeah, 19 volts. Here we go. So then we need to follow that. So that comes down here. It looks like there's a solder blob on a jumper to join these two. And then that comes over to this MOSFET. So this is either switched on or off, depending on if it's in DC supply or battery supply. It's tied in with that, I think. So if we have a look now, I bit my tongue, so it's a bit hard to talk if I sound a bit odd today. But this side we've got our gate down here, and then our drain's going to be these ones, I think. If we have a look at that, so that's our 19 into the FET, and then if we have a look at the other side of the FET, what have we got? 19. So there's power going through the FET. And if we look at the gate, that also has a voltage on it, so that stands corrected as to the fact that that's turned on. So that comes over to this MOSFET. So on this side we have 19. So still following it through. It then goes through this resistor, which is a pretty low value. On the other side of this resistor, what have we got? 19. So it's not that. Okay, now where else does this go? You can see these through hole wires there go through the board. So we've got our 19 volts there, and it's going through to the other side. So I think we need to jump through the other side to trace that through. But we can also see on the same trace here two resistors, 2.2 ohms each in parallel. That'll give us about an ohm, and we're going to have our 19 volts on that side. And on this side we're going to have still our 19 volts, so they haven't burned out, which is good. I was going to flip the board over, and I put my hand in this area, and these are getting very hot. One of these especially. One of them is. I don't think all of them are, but something here is getting very hot. There doesn't seem to be anything physically obvious other than a bit of fluff, and there doesn't seem to be much on the other side of the board where these are. I'm inclined to say that top right capacitor there has the most heat coming off of it. Let's take a resistance measurement there and see what's happening. But as far as position goes, there's the fan, and they come down from the fan, and it's just under the fan. on the other side of the board, not where the DC jack in, but as I have flipped it over, you can see the markings on the board with the model numbers and so forth. So right, so let's have a look. One probe on ground. Any of the exposed copper pads with screw holes are good grounds. And if we probe one side of Mr. Hot Pants, 16 meg ohms. If we probe the other side, that should be our ground. And it's not, which is a good indication that you haven't got a good ground. So let's try another pad. Either that or this doesn't actually connect to ground. No, that one doesn't. What about that one and that one? No. Well, maybe they form a different circuit that don't go to ground. Let's just probe directly across the cap then. There's plenty of resistance there. So the cap's getting hot, but it's not because it's passing current through itself. We'll try the other caps in the area. That one's alright. And that one looks alright. So there's only two caps there. So maybe it's those transistors getting hot, because there really isn't, well, there is something on the other side of the board there. I'm going to have to remove the heat pipe, heat sink setup for the CPU. It seems to be hidden under there, and that's likely where the rest of the problem is. So here is the offending area, and I would say the heat is being derived probably out of that one, unless one of these other caps is bad, which I really hope it is, because I don't know what that chip is. I got no idea, and I doubt I'll ever find out. And I don't have a donor board, so let's plug it in, find out what's getting hot. I'll just cover it in some alcohol, isopropyl alcohol, before I plug it in, and we'll see where it evaporates away from. Plugging in now. Whoa, immediately off that chip. Immediately off that chip. That sucks. That sucks. Okay, maybe it's not the chip, maybe it's like something it feeds which has an overload on it. So I'll plug it in again so you can watch that, or just get a bit closer. You can see it. Yeah, immediately vaporized. So we know the heat's being generated in the chip, but that doesn't mean the chip is at fault. So we need to do some measurements in the surrounding areas, since we don't know what that is. I don't see any inductors, so it's not a switching regulator, but it must be some kind of regulator. And the position it's in, well, that's the wireless LAN port. So let's do some resistance measurements again with the beep on, so hopefully you can hear that. And if we measure around some of the capacitors in the circuit, they all sound pretty quiet. But not that one. Okay, so this capacitor is on a line that is a short to ground. It does not mean that the capacitor is shorted, but this side goes to the IC. I'm thinking this side goes to ground, but we'll see. We'll flip the board over and see if we can't follow this through hole and this through hole. But yeah, we've found a line that has a low resistance to ground. Showed up about 2 ohms, which is passing a lot of current through our poor little IC, which I hope hasn't died in the process of being plugged in, but we can only hope. If I, yeah, okay, let's see if I can follow the traces and see if we can find the cause. I am tempted to just remove the IC because it is what got hot, and it wasn't the cap that got hot. Still, anything's possible. So okay, I tried to trace it through and I ended up down here, and with one side of the cap coming through to here, which disappears into the board, and the other side coming down to here, but there's a definite split, so I'm pretty sure that's ground. If we went from that point to ground, it's a direct connection. So if I go from ground to the top of the cap, just make sure I get a good connection. So that's 2 ohms. If I go to the bottom of the cap, that's 0 ohms. So that is our ground on the bottom, and power on the top, and I'm picking, but this is getting hot because it's actually feeding power out down this trace, which is being shorted to ground. If I knock that off, I'm thinking it's the capacitor. So I'm going to remove the capacitor and we'll check that. Oh, that came off real quick. No loss of heat there. See if he has a no resistance. Nope. Just flick it around. Oh dear, he sounds okay. So what about back here? We still have our low resistance. Yep. Now I need to take the chip off and see if it's that. Just keep the hot air away from the board for a bit of a distance, a couple inches or so, just to warm everything up. It'll likely have a pad in the center that takes a lot of the heat away. Slowly coming in. There we go, there's a pad in the middle. So we decided our bottom side was supposed to be ground, which it is, and our top side, 2 ohms short on it still. That's really good to know, because that means it wasn't the chip. Okay, so tracing this this line that we've found that has a low resistance. Now flip the board over. This is the underside, and these components are directly under the IC that we just had a look at. And so with one pin on a known connection that I've spotted through these through holes, just sort of tracing the lines, and I went from a known spot, and I just started poking around because it came through to this other side of the board here, and it ended up diving off into a center layer. So the only thing you can do there is just keep probing around, and if it's a power line, maybe it feeds another chip or something. So I was looking around, I was running the probe along every pin of these chips, looking for a direct connection along here and here. There's our CMOS backup battery, and heading on down over here, and I find this IC, and running along the pins again, and I come to this pin here, which gives me a direct connection to that voltage rail, which I'm presuming is a rail. And then when I jump on the old Google, I can't find a data sheet for this, but I'll show you what I did find. It's an IT8517E. In fact, I think I know what I did wrong. I think I typed in ITE 8517E, but it seems to have accomplished the same task. Oh no, I did leave the E off. So typing it in Google here we go, and the first result, see, none of these I could really find something that gave me an exact data sheet, but the first result takes me to this PDF, which seems to be a schematic for some model of laptop, and I haven't quite worked out what one. But the good thing is they use this chip, and if we have a look in here, there we go, ITE8517E, and indirectly that gives us the pinouts. So who needs a data sheet? And the pin that I was looking at came over to being pin 50, which is right here, and that's bunched in with a whole bunch of other pins, which is our main. We've got V standby there. So, and if we have a look further up here, we can see that V standby connects to a 3.3 volt line, which is always going to be present in standby. So that must power whatever low functioning circuitry needs to exist for it to, I guess, turn on. Maybe it feeds memory as well for standby states, sleep mode and all that. I don't know, but at the moment it is generally a standby rail, and we certainly have no standby functionality. It'd be interesting to see if this same schematic went off to use that same little IC, if that is a regulator IC. But yeah, that gives us a clue. So we know now that it is very likely to be 3.3 volts on that line. And what we could do is take that chip off. I should have just left it off, to be honest, but we take it off and we can connect our bench supply to that line, and because we don't want to keep frying the chip in the process, and see what else gets hot further down the track, and that might help us locate what's going wrong. But for now, we've got a good starting point. The chip is not the cause of the problem. We can leave it in place while we apply a voltage to this line and see if we can make the actual problem get hot. Now, I'm pretty sure the chip is only getting hot because it's feeding the short. So once we feed it externally, then it's not going to get hot anymore. Well, the actual fault is going to show itself, hopefully. So we'll pick on a ground. Here's a ground pad, and it won't matter if we attach to this because we can always wick it off later on. A bit dirty as well, that's fine. Find a little bit of stiff wire to use as a contact point. And one for the other pad. Now of course we want to be careful with attaching to a little pad like that. We don't want to rip the pad off the board, so what I might do instead is find a bit of flexible wire so that there's a little bit of give instead of a solid point that can be tugged on. Not that that particular pad looks important, but there is a trace coming off that, and we don't want to separate the lot because then it goes through the board and then we're all over. Just becomes a problem. So there we are. So it allows the wire to have a bit of flex without yanking on the pad itself. Okay, with the power supply set to very low current and also not exceeding, I'll say 3 volts, even though it said 3.3 on the schematic. We've got 130 milliamps, so I'm just going to check our initial chip, of course, and I don't want anything in that area to get hot. Okay, so we're at 1.5 volts is delivering half an amp, so we know it ducts through to the other side of the board. So what I need to do, and there's a lot of thermal mass in this board, so I'm thinking it's going to take a while to really become apparent, but we'll see at this level if we can sense anything. Very gently. Now we'll come up to the chip that the power goes into that we found. Possibly a little bit of warmth. It's sort of about 18 degrees inside at the moment, so there's the board is not overly hot, so any warm spots should start to show themselves. And I think it is around this chip. It just has a slightly warmer feel to it. We'll just have to let it sit and bake for a little bit longer. Yeah, I'm at 650 milliamps. Oh, that made it obvious. That chip is very warm. Yeah, it's getting very hot. Oh, that sucks. That chip does a lot. It's the interface between many of the many things as far as I could see. Yep, alright, that's definitely that chip. Just have a quick look at what it does connect to, but it looked like it was the keyboard interface. Really appears to be a system management chip. It does thermal management, it has fan control, it does the keyboard, it does looks like the power button, associated lighting, you know, the whole lot, this little chip here. So I'm thinking because that chip's getting hot when power's applied, the fault is in that chip. I highly doubt that it then feeds something else, which is the problem, because I mean we're not even at what voltage were we at when it was 212, floating around 2 volts, so it's not even full standby voltage yet. So yeah, it's a bit of a shame. That chip is the problem. And an even bigger problem is, where do I get one from? Well, I found a chip on AliExpress, and silly me, I got stuck into it and forgot that I was actually making a video for you, so I've already removed the old one. There we go. And I ordered 2 of them just because it didn't really cost any extra. They're quite cheap. Yeah, nice shiny new chip. And we will go and fit that now. And I have got it up the right way, I hope. There we go. Oh, it's almost perfect with the first drop. Couldn't do it better if I was a pick and place machine. Push it down, we'll take down a couple of corners. Won't matter if they're blobbed out, and I'll hold it down, we'll clean it up later. So now we will run along them with the tweezers, make sure they're all seated. Might seem like a lot of pins, but I think it is worth doing. So we will check the capacitor that we measured previously and our ground side. Let's put that on again. Ground side is ground, and the other side that we had 2 ohms short is now not. No. So that seems to have, replacing the chip seems to have cleared our problem. Now all we have to do is try and turn it on and hope it actually works. So let's just go to the power, or the board LEDs, and I will plug it in, and I will push the power button. Huzzah! Look! Green light! Green light! Green light! And a white light on the power button board. So that's excellent. I won't leave it on too long, there's no heatsink. Get you a shot of the very dirty screen here, and we're plugged in and turning it on. Asus! Who saw that? Was that too much glare? I saw it. Ooh, Windows logo. Dun, 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 dun. Am I truly successful? This chip does a lot, so you know, the mouse, the keyboard, everything's going to have to work. Okay, as you can see, we've got all the LEDs and the charging LED, so it is charging. Power charging, hard drive activity, Wi-Fi, caps lock, number lock. Okay, caps lock and number lock are working, so the keyboard must be working. It's responding, it seems to be booting and stuff just fine. So
thanks for watching, and hope this helps you in your endeavours for similar problems. Catch you next time.